All right, I think we're live. Welcome everyone to this front-end performance workshop. My name is Serge. I am a developer experience engineer here at Sentry. This is actually my first workshop, but what we're going to be going through today is a hands-on workshop to master errors in performance monitoring in Sentry. We have an e-commerce website that we built. It has some issues. We're going to go through a couple of modules like setting up performance monitoring, optimizing your web vitals, distributed tracing, and backend performance. We're going to look at session replays and logs, and we're going to talk a little bit about AI-powered debugging, production readiness, and kind of next steps. I'm going to give it maybe another minute. This is being recorded, so if you are participating right now, say hi in the YouTube chat. And for those of you watching in the future, what's up? And we'll try to make it in the 1 hour mark. We might go over a little bit, or we might end up early. Live demos are hit or miss. I prayed to the demo gods early today to make sure that everything goes smoothly, but hopefully everything works. And so, yeah, let's just get started here. Some of you might have seen the guide earlier. We sent out an email. If you haven't, it's at sentry-build-frontend-performance.sentry.dev. Go ahead and get started. For us to go through this, I'm going to be going through this locally. Feel free to follow along. Feel free to just hang out and watch if you want. But what we'll need is Git, Node.js, and PNPM on our local machines. And additionally, we'll need 2 Sentry accounts, one for our front-end application, one for the back-end. For setup, we have the demo application available at this URL here. This is Sentry Build Front-End Performance Workshop app. Go ahead and fork it. This will create an instance of this on your local GitHub account. And then you don't have to do this now, but if you want, you can also leave the fork network. This is a little bit of a nuance, but for us to be able to do the GitHub integration properly, to see all of the AI debugging features that we have, it should be its own standalone repository, and then we'll see how to configure that integration in the last module as well. Once you have it cloned, you can use HTTPS or SSH. Make sure you put in your username here instead of just leaving it as your username. And then I'm calling this folder unborked. That's what the application is called. So we're going to go ahead and CD into it. And what we're going to do is we're going to install the dependencies using PNPM install. And one more thing to call out here is we have this PNPM Playwright install, which will also install Playwright, which is kind of like your local automation browser tests. We'll be using it to generate some traffic to your web pages that simulate kind of real life traffic, because when you're working locally, you're the only one developing, but it's always nice to have some kind of data that you can feed into it. You can configure it to do things in many different ways. But yeah, I've done all of these steps locally already, so I just kind of skipped through them. If somebody is going through it right now and is having some issues, let us know in the chat. We have our team, Lazar, and some other people that will be happy to help you out. So once I have the app, let's take a look at the structure. So it's a mono repo using Turbo Repo. We have 2 apps. One is called the API. The other one is called Web. So API is our Express node server with using Drizzle as our ORM. We also have a Postgres database, and we have our Web folder, which is our React app using React Router v6. Again, you can be using all kinds of different technologies, but for this use case, I wanted to showcase kind of something that isn't the latest. For example, from like React Router, there's React Router 7. I didn't want to do this in Remix 3. It just came out, but we'll give it some time. And yeah, what we're gonna set up next is our environment variables. So you'll have one for the front end that is gonna live in appsweb.env. And for now, we're just gonna give it the base URL for our backend to make sure that our API can communicate with our backend. And for the backend, there is for us to be able to set up a database. I mean, if you have one, that's great. We have this pnpm db new command, which will actually go ahead and spin up a fresh Neon database for you, and it'll create a .env file for you. It'll put it into apps.api.env with a database URL key. That makes it really easy. It will be temporary. I think it's there for a week. If you want to claim it, there's a URL link in the env file as well to link it. Makes it really smooth for us to be able to get started with a Postgres database. And this is just manual setup if you are not going that way, and if you have a Postgres database. But yeah, we'll add the Sentry DSN in the next module. But for now, you'll need to run these two commands, which will essentially set up our migration from Drizzle to set up our schema for our new fresh Postgres database. And then you can seed it with some test data that we have available. And now we go ahead and run pnpm dev. This will spin up the backend and the front end, and you'll have two separate URLs, one for localhost, which will be our front end, and one for localhost 3001. Oh, API product. So the API endpoint works, but this is our API backend. Yeah, this is a storefront that's pulling in some product from the backend. It has authentication that's very simple using just local storage and some like a context provider from the front end. Obviously, your authentication system will be set up differently, but for the purposes of this demo, this is kind of what we're going with. You can add items to cart. There's a couple of other pages that we're going to go through, but now what we can do is we can go ahead and set up Sentry. And for those of you who are here and this is your first time hearing about Sentry, welcome. We are an error monitoring solution, observability solution, and a whole lot of other things. We recently launched logs, we have session replays, and we have our AI debugger called Seer that helps you in all sorts of cases, both locally, in pre-production, in like your PRs, as well as in production. Like I said, we will need two projects set up. And so if I go to my Sentry dashboard, I already have pre-configured an unborged backend, which is using Express, and unborged frontend, which is using React. So for you to be able to get your DSN values, you can hit this settings cog and then go to your client keys, and you'll be able to get this DSN. This will go into the backend env file. And so if we go to our code, api.env Sentry DSN. So I've already put it in there. And same thing for the front end, web.env Sentry DSN. To install the Sentry packages for the front end, you'll be using our Sentry React package. So you go ahead and install it with pnpm add Sentry React. I'm just going to go through this to make sure that it's available and it's the latest. And we are going to set up the instrumentation for our front end. So this is an instrument.ts file that will go into apps web source instrument.ts. Instrument.ts. And we'll just quickly go through this file together. So what we're doing is we are importing Sentry. I wonder if this actually is helpful or not. We're importing Sentry from React, and we're also bringing in some APIs from React Router DOM. This will help with our React Router v6 browser tracing integration. Essentially, this is a superset of the Sentry browser tracing integration with specifics for React Router v6. We also have v7 version, and there's a couple of different integrations that will probably be specific to your use case. We're also enabling logs. This is a fairly new feature. It's been in GA for just over a month. And we're setting up our integration. And there is this new experiments that came out in 10.13, which enables standalone LCP spans and CLS spans. This helps in moments where you have a page load, and typically we would be tracking page loads with all of these web vitals on the page load, but sometimes content will shift after the initial page load, and there could be some large contentful panes that happen after the initial page load. So this is an experiment we're testing out to make sure that those are still tracked and are part of your spans. We also have our console login integration that goes with the logs, and this makes sure that any logs that you're just console logging to the browser will end up in Sentry logs, which will help you debug with additional context of things that are happening. We have our replay integration, and there is a few configurations you can set up for that for masking text or inputs and media. I'll show you when we talk about it in the replay module, but this essentially helps you kind of preserve your user's privacy and configure it in a way that you're comfortable with or you need to. We have our trace sample rate, which essentially dictates how many traces we're sending to Sentry. I have it set at 100 here. This will depend on your application's traffic and among other things. I have it set to 100, but you can configure it to something like 0.1 if you want only 10% of traces. And that's that. Trace propagation targets. This is what enables us to do distributed tracing between our front-end application and our backend. This is the environment variable that we had put in before, which was our backend API, localhost 3001. And we have configured our session replay sampling. So you probably want to make sure that you have your error sample rate set to 100%, because this will make sure that anytime there's a error that happens on the front end, you have a video-like reproduction in replays. And then the sample rate will be there to bring in sessions that potentially didn't have any errors, but you still want to take a look at how your users are using your application to spot some different things. I'm going to set it here to 1.0 for this demo, and then send default PII, which essentially just configures default personally identifiable information that gets sent to Sentry. In our context here, this will be for replays. For example, if you have it set to false, all of the replays will say anonymous user. If you have it set to true, this will actually bring in the IP address from the user that is accessing your application, which helps kind of figure out maybe geographical locations. It still won't send details like your passwords or emails or anything personally identifiable, but this helps in certain cases. So we'll save that, and we'll go back, and I see there's an error in someone's setup. Thank you, Sentry, for helping look into that. Kind of covered all of this here. Yeah, one thing with the React Router integration, we have parameterized routes. So like, for example, your product route, which has the same template for all of them. And instead of there being separate traces or separate collection for product/1 or product/10, this will kind of co-locate all of them, because chances are if you're having issues, it'll happen across all of them, and it'll reduce some of the noise in your Sentry dashboard. There was also an idle timeout that is by default set to 1 second. we set it to 10 seconds just to make sure that we are still sending data to Sentry if things happen after the initial 1 second load. So sometimes you'll have slow performing APIs or some interactions that take longer than a second. We want to make sure that we capture that in Sentry. You can probably remove this after you've tested your application and everything works as expected. We'll set up an error boundary component to make sure that if things go broken, we have a nice display and Sentry is aware of something going broken, and we can send out an exception to Sentry. That'll go in components error boundary.tsx. And we will import this into main.tsx. So go in, update this. And so this sets up instrumentation in the beginning. Make sure this is the first thing that you import because you want to do this before any of the resources start loading or any interactions start happening. We also have the Sentry React error handler for React Router DOM. And now we can wrap our routes. So if we go to app.tsx, you can see all of our routes here for our application using browser router from React Router. And now we're just going to bring in Sentry routes, which will be configured here. And we wrap all of our routes with that. And we provide the error element error boundary to all of our routes in case something breaks. And we see that error boundary sends out an error to Sentry. We've already done this, and that's where you find it in case you are lost. We'll also run through this real quick, which will upload your source maps to Sentry. When you're doing debugging, the last thing you want to see is some minified code that is impossible to parse. We have this handy wizard that will be able to configure that for you and automatically deploy your source maps anytime you run a build of your project. And hopefully demo gods are with me and this doesn't take long. Let's try that again. Of course, this doesn't work, even though I tried this an hour ago and it was fine. We'll look into that. I've already done this before. What will happen is it will also create a Vite configuration for you, and we're just going to add that manually. That will have the Sentry Vite plugin that we're going to bring in from this would have been a lot easier if it worked, but let's go Sentry Vite plugin, Sentry docs, React router v6. Is my internet down? What is going on? Let's try the wizard again. I'm not sure, but of course, there we go. Yeah, we're gonna install, even though there are some uncommitted changes. You should probably commit those before you do this to make sure that you're not overriding certain things. And I have a Sentry account. It's in my unborged front end. We're going to connect that. It already knows that I'm using Vite and I'm using pnpm. Lurko, I'm sorry. Yes, I am using a Mac and the commands are Mac specific. So I'm sorry. Windows commands need to be updated. We'll make sure to do that. While that's happening, I wanted to just talk through this before I'll update this, but we're also going to be adding this React component annotation to make sure that anytime a click happens and we're recording it with session replay, instead of just getting the DOM element, which is going to be a button with some Tailwind class names, this will be able to traverse and understand which component that actually came from. So again, makes it a lot easier for debugging. This does have a little bit of impact on your bundle, so keep track of that. And if there's any issues, let us know. Let's see where we're at installing. My internet is not cooperating with me. I wonder if we can set up the backend as well. So, oh, and another thing that we want to do as well is we have our authentication context, which essentially makes sure that this is what controls your logout, login, registration functionality here. Again, it's very basic, but what we want to do is we want to bring in Sentry to be able to set a user identifier anytime a user is logged in. So we're going to put it before this login successful console log. And then when a user is logged out, we also want to make sure that we clear that to null. And that way you'll be able to see and correlate replays with specific users to make sure that you understand if something goes wrong for who it went wrong. This is a really cool feature. Let's go back. Yes, that's completed. Are you using? No, I'm not. And so now if we go back to our V plugin, did it not override it as I expected it to? Well, we'll do it ourselves. Search.tech, V plugin. That should be fine. Oh, we do have a newer version, which I think should have it. Yes. So we're going to go in and bring in the React annotation. We're at 25 minutes, so we're going to have to speed it up a little bit. I see Henri Helvetica's there, who's also speedy, so let's try to keep it going here. And now we can run pnpm build, and this will build a production bundle, and Sentry will come in and do a source map upload. You can see that here as well. Awesome. We are almost ready with Sentry. Set up the users, and now if you look at the application, which should be running, we get our products loading. Click around, and if we go back to our projects dashboard and we go into our front end project, we should see some traces coming in within the last 10 seconds. Just to confirm, our network, we should see some envelopes being sent to Sentry. There we go. So there we go. We have some spans being loaded. Spans are essentially the smallest unit of data available in Sentry. It combines into traces. And if you wanted to take a look at what a trace looks like, this gives you a waterfall view of all of the things that happened, how long they took, and this gives you a really good insight into the performance of your application, both from the front end and the back end. Let's quickly go back and set up our backend. We're going to bring in our instrumentation on the backend. Again, trace sample rate, console login integration, and logs available here. Drizzle is configured, so you will see actual like when you create a Drizzle query, it will translate it into an actual SQL query. And we'll see that in a little bit. And we want to make sure that we configure the API. So we bring in the instrumentation. And the one thing we need to do for Express with Sentry is we have to do this Sentry setup Express error handler. And we should be off to the races. Again, Sentry DSN, make sure that's in your environment variable in your backend. Where are we at? Now, if we reload and click around and we check our backend traces, we will go in and bring in both. So onboard backend, onboard front end. And if we go to even like the last 5 minutes, maybe we'll restart the server just in case. Live demos. Yeah, we have our backend spans coming in here as well. And you can see distributed tracing do its thing. So when the client sends a fetch, that's a, let me zoom in a little bit here. Sends a fetch to get product. It gets the handler from our server and pulls in all of the spans and their associated performance metrics here. All right, that's module 1 under our belt. Let's actually look at optimizing Web Vitals. And so e-commerce websites are, you want people to make sure that they load the products quickly and are able to check out. There's a lot of studies around about the speed of your e-commerce website directly correlating with your checkout conversions. And so if your website feels slow, people are going to bail out. If things fall out of place and people aren't able to click on the things that they want to click, that also causes frustrations. And some of those things here, when we're debugging locally and we're using good internet connections, not like the one that I have here today, but if we refresh this page, for example, on the homepage, things come in pretty quickly. The problem with that is a lot of your users won't have kind of really fast internet connections. And so what we can do is go in here, and I have a command that's going to generate some usage on your application. I'm going to run it here. And while that's running, we're going to talk about some of the web vitals that Sentry collects. These are actually core web vitals that Google provides. We have LCP, which is largest contentful paint. So how long until the main content is loaded, cumulative layout shift, how much content moves around while loading or after loads, first contentful paint, how quickly user sees any content on the page, time to first byte. So this is kind of like how long a request took to initially respond. Usually this will be backend related. And interaction to next paint, which is kind of like how long it takes for a click to be interactive. So if you click a drop down and it takes a second to actually pop up, that's a poor interaction to next paint. These metrics combined generate a performance score in Sentry from 0 to 100. And the two things that we're going to look at in this module are our homepage and our sale page. So for the homepage, again, when we are debugging, we are at the grace of fast internet, and sometimes things are all served locally. And so a lot of the time, it's really hard to actually get like real user metrics in here. So what I like to do sometimes is I'll just pop this into incognito. I'll set my network to like a fast 4G. And if we look at the homepage, in this case, things start to load a little bit slower. But the bigger problem is like these images are loading very slowly, and this banner that shows up that checks whether a user is signed in or not, and for users, for like brand new visitors to the website, there's like a new customer promo code. But for example, if like you're on here and you're about to click this button and then it loads, you missed the click, and that is why cumulative layout shift scores are tracked and why it's important to make sure that you have a good one. Close this. Let's go back. So let's take a look at what this looks like in Sentry. To find your web vitals, you're going to go to Insights, Front End, and we have this Web Vitals tab in here. And we can see that the performance score on the homepage isn't as good as it should be. There is a pretty poor cumulative layout shift score. Time to first byte is fine, which is great. But our first intentful paint and largest intentful paint are definitely lacking. You can see what the opportunity is to improve these scores based on what the score is. And so cumulative layout shift and LCP are both in that category. The root cause. So one of the things that's happening in this product card component, if we look at it, let's close a bunch of these down. Product card, you can see this image being loaded, but it actually doesn't have any width or height attributes on it. And the wrapping element isn't set up. It doesn't know what size the image will be. So what happens is initially it loads. It doesn't know what kind of image is going to come in. So it's all stacked together. It gets the image. It understands its size, and then it kind of resizes itself, which causes a jump in the cumulative layout shift score. And so to fix that, what we would do is we would bring in and the other thing is the promo banner. It doesn't render anything initially. Then it checks for whether or not a user is authenticated, and then it pops up, which causes that kind of initial pop-up of the product banner at the top. So to fix both of those things, we're going to bring in some Tailwind CSS, which will give it an aspect ratio of a square. So it knows that the image, depending on its height, it'll be the same as its width. We also bring in the right width and height attributes for these images. Again, these will vary depending on where these images go. Loading eager is something that you want to put for images above the fold. This will prioritize their load as opposed to other images. Again, right now we're just putting it on all of it. And we had some decoding, asynchronous decoding for it. Make sure that it's a full image with a full height. And so if we save this and we optimize our promo banner, and now if we go back to this page, things are kind of already in its place. Again, not the best user experience to have something blank here. You can think of it from like, maybe we'll position it absolute rather than relative in the tree. And the more important thing is like images are already placed. The product card itself already has the right amount of space allocated for those images. One thing that we're not going to do here, and what we're doing is like, it's fine here because it's already on our disk cache. But again, if we go back to incognito and we try to load these, you see like there's no stacking, but the images are still taking a long time to load. And that's because we are actually using the GitHub source for them, which serves an unoptimized version that is like 1.5 megs or something. And that's not ideal. What we want to make sure with images is, where did I have some? I have a section here in the guide. So images are going to come in from different places, whether they're local, whether they're from a CMS. Make sure you're setting up a source set for different images to be served in different viewports. So if it's in a product grid, it might be a small image that you're serving there. Take a look at image optimizations with like different formats, WebP, and stuff like that. And then if it needs a bigger size, so for example, on the product page itself, this is where you would probably want to put a bigger version of that image. We're not covering that in our workshop, but if we take a look, we do a couple of more refreshes here. We should be able to see some improvements. Already at 86, already you can see the CLS score is at 0. Again, there's still some work with first contentful paint, but that might also be like some users will have slow connections, which will impact your performance. This is where you would dig in and better understand the use cases here. But we were able to fix that part of it. And the other issue that we had was our sales page. So the sales page actually does not render anything for initially. And for a new user experience, this might be, oh, the server is taking a long time, or something's going on here. And what we can do with Web Vitals is better understand whether or not this is happening on the front end or the back end. And if we refresh this, we should see sale page, and the metrics might have not come in yet. And so it's saying it's good. This is a quirk of the dashboard. We're constantly working on improving these. But at some point, those should be bad. And if we look at how the sale page is set up, well, turns out that we're actually just returning null, which doesn't render anything on the front end while we're waiting for the products to come in from the back end. Again, this is something that probably is pretty obvious, but a lot of time AI written code might not have all the context of your full application. And technically this code is right and it's doing the thing that it's supposed to do, but is it doing it to its best ability? So being able to understand and dig into these situations is really important. And so what we can do to fix this is provide a skeleton experience for us to be able to fix those. So if we go back to our sale page and we update that, now if we go here, anytime you refresh, at least a user is initially able to see what this page could look like, and we're just waiting for the data to load from the backend. We're at 38 minutes. Take a sip of water. How's everybody doing in the chat? Doing great. So kind of best practices, nice skeleton layout to the actual content. We can have some subtle animations, pulses, shimmers. Verify your improvements. Let's see if those came through. If we go to the sale page, we're at meh. But if we dig into it a little bit more, we can see there was a around 65 score here, and we were able to get all the way up to a pretty good score. And you can see there are some traces that are really poor, and those were the ones where the largest contentful paint, which was also the first contentful paint because we were waiting for data to load from the backend before showing anything, was over 2 seconds, which is definitely no good for this. And we were able to update that to 120 milliseconds because we were able to kind of show everything with skeletons early on. That wraps up our Web Vitals section. So again, if you want to learn more, we have a link to our documentation somewhere in this link here. to Sentry. We can also probably drop it in the chat for anyone that wants to learn more about Web Vitals and how to optimize them with Sentry. Images have explicit width and height. Image containers have aspect ratio. We are loading images using loading eager. For below the fold images, we can also optimize it the other way, where it waits for everything else to load and then it renders in images below the fold. Talked about skeletons, and we tested it on real devices with flow network connections. This is an important part of the debugging process. Playwright makes it really easy, because if I take a look at Playwright, this is a quick aside, but generates home traffic, you can actually emulate network connection conditions, which pulls it in straight from the Chrome Developer Tools API. And so you can set it to a download throughput for 4 megabytes. And you can definitely configure this. And so you can have these to mimic real-time, real user usage while testing it locally, which I thought was really cool. Now we're quickly going to talk about distributed tracing, because even though we fixed kind of the front-end performance issues as much as we could, there is still an issue of these products taking a long time to load. And to be able to take a look at that, what we can do is we've already double-checked that distributed tracing actually works. But yes, the Sail API is slow. So for this one, we're also going to generate some traffic. And again, this is using Playwright. And this will actually do it for a little bit, but I think we should start seeing issues come up for it immediately. Because one thing that Sentry does is it also, even though this is not technically an error where something is broken, Sentry will have automatic issue detection for N+1 queries and consecutive DB queries, which probably in this case are similar. And you can see these are popping up last seen 10 seconds ago, 9 seconds ago. And so what happens here is it will give you the actual transaction, which is the API Sail endpoint. It'll give you the span, which is actually the DB query that is used for this. And when you look at the trace view for this, it will light up with these alerts, and you can see this waterfall view where every single, it's a loop that does a DB fetch every time it goes through the product. This will probably be more pronounced in our trace view. And if we look at this trace here, yeah, you can see get API Sail, and then you can see for every single product we have, it went in and it fetched the sell price for it. Yep. So this is where we're at. Understood the N+1 query issue with our trace waterfall. And what's actually happening is in our Sail API, we have our all products that we're fetching. And then we have this loop here that goes through all of the products and it finds the sale price for it. And if there is a sale price, it pushes the sale product to our array before returning it to the front end. Again, this is not something that most of you probably would write. But AI-generated code might not know about it, and there's probably a lot of bad code that lives out there that it is trained on. And so being able to identify and spot these issues using Sentry is really important. How do we fix it? Well, there is SQL joins. And again, shout out Drizzle. It makes it really easy for us to set it up. We're just going to go ahead and copy this file into Sail. And what happens here is we have our one query now, which we also can wrap into this sentry.startSpan function, that we can define a custom span that will show up in the waterfall view. So this makes it really easy for you to pinpoint certain critical parts of your application and explicitly define the query that you are, or the span name that you want it to be, and then you can search for it easier in the trace view. You can set up alerts for it, and you can set up dashboards for it. So Sentry start span is definitely a low-key feature that I have been using a lot more since joining Sentry. But the actual fix here is using inner join for sale prices and left join for the metadata. Inner join, what we'll do is essentially, if there is no sale price available, it won't return this object. And what left join will do is, if there's a sale category missing, it'll just set it to null. So we want inner join to be able to not fetch products that don't have a sale price associated with them. Now that we saved that, if we go back to our application, there was an error, but we can now see it is loading a lot quicker. And if we were to take a look at our traces again, let's take a look here. These are old, 3 minutes ago. We're going to wait for some traces to come through. And another way to take a look at your API latency is, we looked at front-end insights for Web Vitals and front-end performance. Backend insights will have something similar, where you can see we have this API latency here, which on average is 2.62 seconds. And with our changes here, we were able to bring it down to below 500 milliseconds, which is a huge win in my mind. And if we were to take a look at our traces again, let's take a look. API sale and just one database query, as opposed to 18 times 3. I'm not doing math right now. I'm already nervous enough. But yeah, this is how you use distributed tracing with Sentry to identify slow-performing database queries, to identify performance bottlenecks in the front end. There is automated issues that Sentry will create for you to help you debug these quicker. We have measured the improvement. We looked at this. Obviously, left joins, inner joins, like, that's one way to do it. But if your database is huge, you also want to make sure that you have indexes enabled. And so this is kind of like a small aside for you to also take into account. You can add indexes on columns that have where clauses, foreign key columns using joins. And if there's columns that are used for ordering, you want to make sure that those are indexed as well. Again, it'd be nice to be able to index everything, but that mostly depends on the database instance that you have. And if you have everything indexed and everything is in memory, that might be another issue for a completely unrelated thing. So keep those things in mind. These are our kind of database performance best practices. And the key takeaways here are, we fixed the front end with skeletons, but then there was still an issue with the back end. We were able to use distributed tracing to figure that out. And yeah, I think we're in good shape for these sections. And we are at 10 minutes, so we're going to speed through the session replays and structured logging. And the idea here is, again, Sentry is really great at error monitoring. And when something goes wrong, you'll be notified using Sentry. But things like session replay, structured logging, these traces are also really good ways for you to be able to have the right context to figure out when things might not necessarily break. And so this is where, if you are following along, it would be nice to update your replay session rate, sample rate from 10% to 100%, because we're actually going to reproduce an issue with our checkout experience. And so the idea is, you've changed payment processing. You now have a new checkout form that you coded together. You had local tests, you were working with Cursor, Cloud Code, and you have this visa that's 424242 with a 3-digit CVV, and you were testing it and everything worked fine, and you deployed the code because why not? But then you started getting alerts or messages from people being like, hey, I can't check out. Hey, what's going on? The checkout is not working. I can't see anything to do. So for us to be able to reproduce that, what we're going to do is we're going to take an Amex card, because obviously you want to make sure that you support both Visa, MasterCard, and Amex. And we are going to log in. And I do have a demo account already set up here. And we're just going to add a few things to cart. And we're going to check out. I'm going to put in 10, 35, 34, and then we're going to do 1, 2, 3, 4. And like, oh, nothing's happening. What's going on? Uh-oh, no indication of what's happening. And that could happen. And there's no errors. There's nothing going on. And a user is not able to check out. So what are they going to do? Are they going to change their payment method and use something else? Probably not, because they want to collect those Amex points. I know I do. So they're just going to bail. And that is not ideal. And this is where session replay comes in super clutch, because we go to explore replays, we'll be able to see, and I'm hoping this is the one. Is this where we started doing some? Yes, perfect. So because it was running in my tab, I didn't refresh. I should have done that. Session replay was actually able to capture the whole trace, or like the whole replay of that browser window being open. It still thinks I'm live. It will probably change that shortly. But session replay gives you a video-like reproduction of all of the things that a user, all the kind of like little steps that a user took before getting to an error, or in this instance, it was a dead click. Should have been a rage click because I clicked it a couple times. I'll take a look at why that didn't happen. But again, it'll scrub through, it'll skip through parts that there was no interaction by itself. We also have this AI summary that kind of goes through. It actually notices that there are N+1 queries. So all of these things are interconnected. Our distributed tracing, our logs, our errors are all connected, and session replay is kind of like one view you can do to take a look at all of these things. What happens in this instance is if we go to logs, and they will be timestamped to this replay as well, and you can start seeing CVV validation failed, expected 3 digits, got 4. Well, that is our culprit. So what happened is in our cart checkout functionality, the LLM decided that, hey, just because you're testing with Visa and it has these, like this data that you provided for this test card that has 3 CVV, I'm just going to make sure that I just check against if the length does not equal 3. And if it doesn't, I'm just going to error it out and return false, not do anything else. Not ideal. But because we had the logging integration enabled and we had Sentry logs enabled, we were able to see those logs in here. And it gives us a good insight into where to go to fix these issues. And so we're going to go and update our cart and change all of this. And essentially what we're doing here is we are adding some other logs in here. And there's a few ways that you can do logging with Sentry. So we have, for example, you can do console logs. And if you're using multiple options, if you're passing multiple options to it, Sentry will actually parameterize these, and you'll be able to query by these parameters in your logs. Additionally, we can do a Sentry logger log with info, warning, error. And we have this formatter that also will parameterize things like the CVV length And so this way you can set up, again, alerts, dashboards, or insights into specifically your logs to figure out usage patterns rather than errors or performance, to get better insights into the overall UX of your application. And so when we're handling checkout, we are checking for CVV validation. And if it's not valid, we're actually introducing some validation errors. We're sending a Sentry log. And now, if we were to go back to localhost, and let's try to check out now. And let's do 42. But let's say somebody made an error and they only put in 2 CVV. Did I save this? I didn't save it, of course. We will be able to see a validation error. So obviously, if you're doing client-side validation, if you're doing server-side validation, chances are you want to make sure that you're presenting errors to your user and not just logging them. So this way, you can see that the CVV must be 3 or 4 digits. So let's update that. 4, 10, 45, 2, 3, checkout, and we were able to successfully process this checkout. Let's close this and let's see if we got another replay. Yep, and we get our logs in here. And perfect. One thing to note with logs, all of them will be available in here. And like I said, let's take a look at the successfully created purchase. So this was a auto console logging one. And if we were to take a look at message parameter 1, which is ID, or is that price? That might be price. Oops, 5 minutes. Last hour. Might need to look into better surfacing what is the actual parameter. Because again, you might have the same format in your console log, but it might, like the parameter might be for different things. So this is live demoing and live learning about our product. There's a question in the chat. What is the difference between Sentry capture message and Sentry logger? That's a great question. I believe capture message will actually show up in your issue feed and it won't have an error associated with it. It'll be a info tag. Sentry logger will be in its own section inside logs. I don't want to speak too broadly about this, but I believe Sentry message was there before logging was a feature. And we also have breadcrumbs, if you have seen those. I think we're trying to move towards issues being specifically for issues, logs being for logs, and there is a clear distinction between them. And because it's all trace connected, whether you get an issue, you'll be able to see logs associated with it that happened before the error or after the error. And yeah. We are at a minute left, but we were able to get through the replays and logging. Again, if you want to check out this guide afterwards, this is where you'll find some of the high-level information, but do please go to our documentation where you'll find a lot more information about logging, session replays for all the different SDKs that we have. Do we want to do a Q&A and then finish with module 5, or are people sticking around for a bit? This one is not really about coding anymore. We're done with the code. We made it within the hour. How are people feeling? let's jump into AI-powered debugging. So what we've done up to this point is we went through and we kind of manually dug through the traces, we dug through Web Vitals and distributed tracing. Let's take a look at how Seer, our AI debugger, can help you do that without you having to do anything yourself in production, and how it can help you in your development and your pre-production workflows. So here we'll be able to, by the end of this module, we'll make sure that we have the GitHub integration set up. We'll understand how Seer analyzes issues, and learn more about kind of like the next steps. I also have a section here about alerts and dashboards. To be able to enable AI features inside Sentry, you'll want to make sure that you have your GitHub integration set up, and inside your settings, there is a show generative AI features toggle that should be toggled for everyone, and AI code review. You'll also want to make sure that you have the GitHub integration set up, which is inside settings, integrations. Make sure that the right repos are connected. This is where we talk about repos. And if you want, there is also Seer settings for auto trigger fixes, which essentially gives you a breakdown of which issues you want Seer to try to auto fix in terms of the actionability of those errors. Again, Seer is a paid feature, so based on your usage and what you feel comfortable with, you can scale this up and down as much as you want. What is Seer? Seer is Sentry's AI debugger. It's your debugging buddy that actually likes doing it. It works with you alongside in development, in review, and in production. In development, you can use the Sentry MCP server that has tools that help you analyze your issues with Seer. In review, we have our AI error prediction, as well as PR reviews that you can just tag using the Seer GitHub app. And again, in production, these are things that when an error happens, Seer can do a root cause analysis, cook up a fix for you, and actually create a PR at the end. It has all the context of all of your errors, all of your traces, all of your source code, because you have your GitHub repo connected to it. So it is the best place to kind of figure out very tough to debug issues on your own. If we take a look at the root cause analysis for production issues, this was me going through the N+1 query that we did in module number 3. But Seer can do it with a few clicks of buttons. You go to the issue, you click the Find Root Cause button in your Seer sidebar. It goes through, it analyzes the distributed trace that we examined manually. It identified the N+1 pattern, and it can actually find a solution for you. So once you click Find Solution, it'll come up with the right solution, which it actually mentions that you need to update imports to include necessary drizzle ORM functions for joins. And there's a button to code it up. And once you coded it up, Seer provides a draft PR for you that you can then use Seer to double check its own work. And yeah, that's high level Seer. And one more thing to keep in mind is beyond kind of being reactive to things going wrong or proactively kind of like looking at replays or traces, you can set up alerts and dashboards for all of these things that will be like your command center for making sure that you keep an eye on everything that's going on. So alert recommendations, error rates for anything that's more than 1% occurrence, super critical on issues in your production. You can set up front-end performance alerts. So if an LCP score, the P75 score for your LCP goes above 2.5 seconds, which is Google's kind of like poor threshold, you want to make sure that you're alerted about that. You want to make sure that your backend performance, even on the slowest queries, so your P70, P95 is less than a second. And you want to set up all these dashboards. Make sure that you have your kind of web vitals trends, your API performance, your error rates, and your traffic throughput. To learn more about all of these, we have some links here for alerts and dashboards. And yeah, we are at the end of the workshop. Thank you everyone for joining and chatting, asking questions. If there is any last minute burning questions, let me know. Thank you for highlighting my wife's comment. What's going on? Yeah. All right. I've been your host for this workshop. Once again, I'm Serge. Have any questions? I am serge.tech on Twitter or serge@sentry.io. Send me an email, say what's up. And if you have any questions about Sentry, I'm always happy to